Okay, well, I really wanted to start off by saying thank you to everyone, and sorry for the confusion about the Zoom link for this meet and greet for today. Um, but I am recording this, so you can watch this at your leisure. Um, but thank you, because the classifications and the activity that you help us with are really not only, engaging our students in understanding research and how to analyze this data, but it's also helping us really to like see things that we didn't think of before and to look at our data in a new way, in a different way. And so we're really appreciative of the comments that you have on the forums, but also just in your classifications have really um shined new light on our understanding of IceCube so far, and that work is deep in progress. So thank you. I also wanted to let you all know that we have our sorry, I'm changing this thing. Show hide this. We have seven different languages for Name That Neutrino. We have had these German, Spanish, Italian, French, and Dutch for a while, but now we also just finished a Japanese translation, so we're really excited about that. And then we also have the way to pick between the translations. I hadn't um, clicked the right box for that before. So now in the top right corner of Name That Neutrino, you can always switch between translations here if you're interested in that, or if you're sharing with individuals who want to experience this in a different language. Okay, so about IceCube, it's this incredibly large global collaboration with more than 350 people working on it. We have 59 different institutions, and we're in 14 different countries. And the science that can be done with IceCube is just like a huge array. We actually have like a world leading record on neutrino oscillations, and I think also dark matter. And so like it's just a huge amount of things that we can study and look towards with our detector at the South Pole. And so there's a picture of me. You can see me. This is one of our recent collaboration meetings, and this is where I'm located in Philadelphia. So this is we are like the lead institution for Name That Neutrino. But as you can see, we're just a part of this very large IceCube collaboration. I wanted to let you know about the South Pole in a little bit more detail today. And one of the reasons for that is because just like 3 days ago, I want to say, we had 15 ice cubers arrive at the South Pole. And we just posted about this on the Instagram, on the IceCube Instagram account. And we have a huge social media presence with Instagram and Facebook and X if you're interested. And so you can definitely check out the handles on the IceCube website. But so we had two planes leave New Zealand and head for the South Pole. And what they're working on now is the IceCube upgrade project, which is this really exciting new construction of adding more strings to the current IceCube detector. And so yeah, so they just arrived to the South Pole recently, and so they're now working on that. So that's just a really exciting um, moment for all of us ice cubers. We also have just like some interesting facts over here on the left about the South Pole. So in the South Pole's summer, which is happening now, which is why we have this construction project happening now, because it's summer in the Southern Hemisphere. And so there are more people at the South Pole in at their summertime, so it's about 150 people. But in the winter time, it's much smaller. And in fact, we don't have planes going to the South Pole anymore once the winter is occurring. And so these people stay. They winter over, and they have enough supplies and everything prepared for that. Um, the South Pole is kind of this wild place where there's no native plants or animal life at all. And so you might think of penguins in Antarctica, which is correct, but that's on the coast of Antarctica. And so the South Pole is in the interior of the continent, and it's just too cold and too windy and too everything that you don't have any native biodiversity there. But of course, humans are there, and so there's about 47 buildings and there's 5 scientific experiments. And in fact, over, I don't know, 70 years ago, there was the Antarctic Treaty, where people's, countries, 12, I think, countries signed this to say that we're gonna reserve Antarctica for like peaceful purposes, like scientific experiments like this. You might have heard about the aurora in the news lately, and that's because we're at what's called the solar maximum. And so the sun goes through an 11-year cycle. And so what that means is that the sun is sending out like solar flares or coronal mass ejections, and of course the solar wind, things from the sun, particles from the sun that then interact with our atmosphere, and our magnetic field. And so the magnetic field has two poles, a north pole and a south pole. And so you maybe hear about the aurora being called northern lights, but they're southern lights just in the same way that there are northern lights from the magnetic field. And so these are some of the photographs that we've been able to take at the South Pole. I say we, as the collaboration. I haven't been to the South Pole. I actually applied for this latest trip and didn't get chosen, but maybe next time I'll get chosen. And this picture on the bottom left is actually my street. I was so excited to see the Northern Lights at my latitude just outside of Philadelphia. Just a few months ago, one of those big solar storms that maybe you heard about. Okay, so the seasons at the South Pole are just really summer and winter. And like I said, we're in the summer season for the southern hemisphere right now and for the South Pole. And so what that means is that, the sun stays up and it doesn't set at night. And so this is sometimes referred to as like the midnight sun. And then the other season, is winter, which is the opposite months. And so then when it's summer in the northern hemisphere, then of course it's winter in the southern hemisphere. That's due to this tilt of the Earth's axis, right? So this is our spin axis. Here's the South Pole down here. And so this is when we're having winter and no sunrise at all. And so this is like the polar night where it's just completely dark all the time. And so there's like a couple animations I have here. So this one's showing when you have like the midnight sun, when you have the sun up all the time, which is the time of year right now that we have at the South Pole. This is Antarctica. We're looking at the bottom of the Earth here. And then this is the opposite, right? Where you don't have the sun coming up at all. And this is where you have just darkness all the time for the winter at the South Pole. And so, yeah, talking about the snow at the South Pole, ironically, very ironically, it really doesn't snow very much at all. And in fact, Antarctica is a desert. And it's just the coldest, driest, and windiest place on Earth. And so there are scenarios where you have kind of like whiteout conditions like this. And so to get from building to building, you would have to, use these flags or maybe your handheld radios, but also they have like ropes that you can follow along. And the reason for that is because of the wind. And so the wind is just kicking up a bunch of snow and giving these like whiteout conditions. But in reality, we only get about a few centimeters of snow per year, actually coming down, from clouds onto the ground, right? So that's really rare. And so what we have, though, over millions and millions of years is a buildup of this snow, and in fact, forming into this like really, really clear glacial ice. And so this is this huge glacier, right, that's on top of Antarctica. So Antarctica is a continent with land mass, but has ice, glacial ice on top of it. And in fact, it's so high that some of our ice cubers that go to the South Pole actually get sick with altitude sickness because it's at this really, really high elevation, over, almost 3,000 meters above sea level. And so this is one of our collaborators. He graduated from Drexel and he is actually at the South Pole. And so we do have a pole that, marks the South Pole. But the interesting thing here is because, actually all the buildings and the pole itself are in the ice. And the ice, the glacier itself is actually moving. So that moves about 10 meters per year on top of the landmass. And so every year, I think it's on New Year's Day, they actually have a ceremony, a pole moving ceremony, where they physically move the pole to the actual geographic South Pole because, they've drifted since they've all been on that glacier. So yeah, so this is like looking up from, the bottom of the Earth. And so the way that you typically get to the South Pole is to travel to New Zealand via like, commercial aircraft, and then from New Zealand on military aircraft to the coast, and then to a smaller aircraft then to go to the South Pole. So here's Antarctica at the South. Here's Antarctica. Here's IceCube at the South Pole, on Antarctica, and the thing I really want to drive home here is that we're using that super clear natural glacier ice as our target. And really, these signals that IceCube detects have always been happening in this glacial ice. And it's not until we built these light sensors to then collect that data. So these particles, from far in our galaxy and outside of our galaxy, these particles will travel and interact with the ice and produce these light signals, those patterns that we see on Name That Neutrino. And so those those light signals, yeah, are being detected by these light sensors that we then put into the ice, right? But the detector itself already was there, and that was created by those like tiny amounts of snow that were building and building and building upon over, millions and millions of years. And so this is actually just from, I think, a few days ago. They were doing some drilling here, and so they used this hot water drill to actually melt the ice. And this is a photograph of one of those holes. And this is part of the IceCube upgrade. And so what we're doing is we're adding 7 new strings, which doesn't sound like a whole lot, but that turns out to be over 700 new light sensors. And the other thing that we're doing is adding like a variety of light sensors that will let us understand a little bit more about like the the properties of the ice, like kind of like a calibration sort of thing. And then, we've done some simulations to find just the right way to install these to kind of maximize um, the information that we need. And so this up here in the top right corner is the artist rendition of like what this probably looks like inside the ice. So if you could go inside of the ice, these light sensors are now, frozen inside the ice because they were installed by melting the ice. So we're detecting these neutrinos, right? And they're these really abundant, um, rarely interacting, kind of mysterious particles that can teach us more information about our universe. And so here's those light signals that we see on Name That Neutrino. They happen deep inside the ice. This is like a 2 scale uh, cartoon of the IceCube lab. So here's the IceCube lab, here's people for scale, right? And so that just kind of gives us a sense of how incredibly large this detector is and how incredibly large these signals are as well. Some of the motivation for Name That Neutrino is that, there's limitations to our machine learning algorithms. And so this is a really good example where our AI, our machine learning algorithm here was saying that this was a through going track. And we look here and we see that there's a lot of noise, right? There's like random bubbles all around here that, is not a clustering of a signal, but instead our signal's over here on the edge. This should be a skimming as the, Name That Neutrino users are able to identify. And so we're trying to kind of put this together, trying to see, why would our algorithms kind of mess up in these different ways, but also can we kind of work in tandem, like hand in hand, like, can we send some signals to our name that neutrino users, and then some signals to our algorithms, and kind of be able to classify, all of our data that way. I want to talk a little bit about the science about like why we might want to do this. And so these are just like a bunch of images of a hand. So on the leftmost picture here is a optical image that is showing what optical light would look like, or visible light. The next image is an X-ray. So this is another kind of light, but it's a different part of the electromagnetic spectrum. And so this is using X-rays, and you can see the bones here. This image all the way to the right is actually using infrared, which is again another part of our electromagnetic spectrum. So still light, but this is kind of like showing the heat, right? So this is infrared all the way to the right. And then this one in the kind of in the middle here is an MRI that lets us kind of see the muscles more. And that's using kind of a totally different technology, right? This is using magnetic fields. And so the point here is that the different ways that you look at something can reveal different information, right? So we were able to see the bones and the muscles, and then actually more like the heat. And then this is like the outermost layer. And so we do this in astronomy all the time, where we look at some object like a galaxy like this, and we can look in those different wavelengths or different parts of the electromagnetic spectrum. So this is light. And so we have radio, microwave, infrared, visible light, what our eyes can see here, Roy G. Biv, and then ultraviolet, X-ray, gamma. So these are all just different categories of different kinds of light that we can look at and be able to see different parts, right? Different structures, different information, kind of glow in different ways depending on the kind of information that you're using. And so with neutrinos, the idea is that that's a new way, right? That's another way to see our universe. And so one of the really interesting things that IceCube has been able to do is to look at our Milky Way galaxy. So I want to just take a minute and talk about that. So maybe this is what you see with your eye, maybe. If you go to somewhere really, really dark, and you recognize that these aren't clouds, but instead that you're actually looking into our galaxy. And if you were able to maybe use a camera that was able to collect more light, you would be able to see, our galaxy brighter, like this. And then I want us to understand what we're looking at. So here's where we are in our Milky Way galaxy, out on one of these like arms of our spiral galaxy. And so this is like if you're looking on the top down from our galaxy, but if instead you were able to go to the side, and kind of rotate that, you would see that our galaxy is like this disk. And so again, we're over here outside on the spiral arms, right? So now we're looking like on an edge view. And so when we look out to the night sky, we could look this way where we wouldn't really see the Milky Way, or we could look this way, right, where we're looking into the plane. And that's that band that you see across the sky. That's this Milky Way, right? And so if you just like cut a slice of this and rotate it, then you can make a picture that looks like this. And if you were able to use really powerful telescopes that look in different parts of the electromagnetic spectrum, like radio and optical, this is like visual, um, and then this is gamma. Again, you see these different things, but what IceCube has been able to do is kind of produce a similar image using just neutrinos now. So neutrinos being produced from our Milky Way, and this was published in Science Magazine just last year. And so this is one of the our newest exciting kind of discoveries that IceCube's been able to do. So this is the kind of science that we're able to figure out what's going on with neutrinos, and can we get a new picture of our universe, right? Instead of using light, instead using neutrinos. Okay, so that's actually all I wanted to kind of let you know about some fun facts about the South Pole. some updates on what's going on with IceCube. The fact that we're literally doing construction right now and that we just had IceCubers arrive just the other day to work on this, during the summer in this at the South Pole. So, that they've got some sunlight and it's maybe not as cold. It's still pretty cold though. Um, and that we really, really, really appreciate the time and effort that all of the volunteers are putting into our project. And we really just appreciate it. So thank you. Okay, I'm gonna stop recording. I'm gonna stop.